call it playtime. Just call it interesting.
Testing,
What's that?
experimenting, getting stuff and seeing the results.
So let's talk about power delivery. This is, I always like to just throw this out there because you have now the ability to understand this. So let's say that I have a power source. I want to deliver power to this load. We'll go with our I mean, these are not going to be standard here, but I'm going to have 120 volts RMS, right? What comes out of the wall? We'll just start there. Everybody's familiar with that. And I want to deliver 360 watts of power. Now, for this simple circuit, we know that power is equal to current times voltage, which means current will be power divided by voltage. So if I take 360 watts divided by 120 volts, that means that I have 3 amps here. Now, I'll go put the arrows both ways because it is easy. And I also have 3 amps down that wire too. So I'm going to invent a whole new that's the word I want to use. Quantity. I'm going to call it amp wire. Now, the idea is what I need here is I need 2 wires that can handle 3 amps. So 3 times 2 is 6 amp wire to deliver that 360 watts. Make sense to everyone? Now, let's change this a little bit. This time, I'm going to take 2 sources here. Deliver that power to 2 different loads. Still want to deliver a total of 360 watts. So with 2 different loads, that'll be 180 watts each. Now, this is going to be 120 volts at 0 degrees. This is going to be 120 volts at 90 degrees. So I'm creating a phase shift, right? I've got these 2 power sources, phase shifted. Now, it's going to be where it's going to be a little bit tricky here, all right? Relatively speaking, I'm going to make this plus and that plus up here, okay? So I'm going to get away from the back and forth arrows and just say, all right, well, if I'm calling that a plus, relatively speaking, that current goes out there, that current goes out there, and then the current comes back there. Well, how much current is flowing up here? I have 180 watts.
Amps.
What's that?
1.5 amps.
Okay, got 1.5 amps there. What do I got down here?
1.5.
1.5 amps there. What do I got here?
3.
No.
Oh, I do. Oh, wait.
Now we get to use our angles. So the current here is actually going to be 1.5 amps at 0 degrees plus 1.5 amps at 90 degrees, or 1.5 plus J 1.5, which is 2.12 amps at an angle of 45 degrees. Make sense to everyone? What is my amp wire total now? 1 wire has to handle 1.5. This one has to handle 1.5. This one only has to handle 2.12. So 1.5 plus 1.5 is 3, plus that is 5.12 amp wire. Now, not a lot less than 6, but it is less. Make sense to everyone?
Mm-hmm.
All right. Anybody see where I'm going with this?
Mm-hmm.
All right. Now, I'm going to build one more type of power supply. This gets a little trickier here, but bear with me. All right, so each of these is again 120 volts. We'll go ahead and use that as a reference. So I'll keep my reference right here. This is at 0 degrees. This one is at 120 degrees. This one is at negative 120 degrees. Because there are 3 separate loads, I still want to deliver a total of 360 watts. So each of these will be 120 watts. Which means the current here is what?
1 amp,
At,
0.
okay. What's the current here?
1 amp at negative 120.
Okay. And then finally this one.
1 amp at 120.
Okay.
Now, in order
Makes
to get
sense to everyone?
yeah, now to order to add them all together, you have to convert the 2 of them amps into the
All right.
Let's
So
do
that's
it
going to
for-
be 1 amp at 0.
Yeah.
Plus 1 amp at 120. Plus 1 amp at negative 120.
and well, you only have to convert 2 of them.
Okay. So 1 plus J 0. What does that end up being? So we're going to take 1 times the cosine of 120 degrees.
Negative 0.5.
Okay. So this one will be minus 0.5. And the sine of 120.
0.866.
Okay.
It goes longer, but that's just a good round.
And then this one, negative 120 degrees.
That's positive 0.5
Okay.
and a negative J 0.866.
Wait a minute.
Oh wait, I put
You got it back.
I put the negative on the outside, not the inside.
There we go. 120 degrees should be a positive cosine, right?
Nope, it's negative cosine.
What is negative? What am I doing?
Negative 0.5.
Negative 120.
Negative 120 is a negative 0.5.
120. Oh, I'm thinking Y. Okay. That's the way to look at it, right? Okay. So X is positive there. That's X, no. X is this way, right? So they're both negative. There we go. They're both negative. Here, Y, right? For the negative, for the 120, it's plus 0.866. For the other one, it's minus J, 0.866. All right. What does all this add up to?
Oh, negative
1 minus a half minus a half.
Negative 1 plus 0, J.
Okay.
J 0.
0 plus J plus plus a negative J, same magnitude. Oh, 0. 0. Now, what does that mean?
Which is something going on.
I only need 1, 2, 3 lines with 1 amp each. So this is now 3 amp wires. Do I even need that one? three-phase power. This is what three-phase and why three-phase works. I've done these numbers at 120 volts, just, we'll keep it simple. Okay? But when you have your high-power transmission lines up on those towers, delivering power from point A to point B a long, long way away, you ever notice that there are always three sets of wires? Always. Sometimes there's two sets of three, depending on whether something's been added or whatever. All of that delivery, all of that power being delivered is three-phase. We can deliver the same amount of power with half the wire, half the copper. Right? Think of what that means, right? If I need 6 amp wires, right? If I need made up, whatever, I need wires capable of handling 6 amps. If I do it with three-phase, I only need 3 amp wires. Less copper. That's why.
Don't you need more sources?
No, we can, the sources, the way that the three-phase works is that the generator is built to generate that three-phase. So it's created within the generator itself. The way the generator is wired, you produce those 3 phases all at once. And for those of you who took the summer class last summer, I talked a little bit about motors and about the fact that a 3-phase motor powered with 3-phase power provides a perfect rotating magnetic field. Better than a single-phase motor where I try and create that rotating magnetic field using capacitor to create a phase shift between the 2 phases. So if you have massive industrial motors that have to generate, draw lots of power, they're going to be 2-phase motors because they just work a whole lot. So anyway, it's something that we can kind of understand. Now that does require the power company to be careful, right? This system is what? This is ideal. Why is it ideal? Because my load on each phase is perfectly balanced. And by the way, this configuration is called a Y configuration. You can also have what's called a delta configuration. If you really want to learn more about that, there's a chapter in the book that covers it. Obviously, I don't spend any time going through that because that's more power related than electronics related. My focus is electronics. But if you're curious, it's chapter is a chapter. Anyway, it's one of the chapters in your book. Oh, there it is. Yeah, if you look at, if you really want to know more about this, chapter 24 is entitled Polyphase Systems. So, this is about as far into it as I'm going to go. Look at chapter 24. We can get into all that stuff. There we go. Yeah, so it starts off right off the bat with 3-phase generators, and then goes into the Y connected, delta system, Y to delta. It gets messy. So not anything I'm going to worry about. Okay. If you ever see voltages like 277 volts for something, where does that come from? Well, if you actually were to see, I'm using my common connection here, right? But if I actually were to connect from this phase to that phase and measure that voltage, right? What is that total voltage? Well, now, if I look at the difference, well, actually, that's going to be a sum. When you do that, so if I have 120 volts at 0 degrees, and I have 120 volts at 120 degrees, right? So if we do that math here, that would be 120 plus J0, and then we do is this the plus 120? Yeah, it's a plus. So I would have negative 0.5, so half that would be negative 60, and then 0.866 times 120. What is that? 104. Remember that, the potential difference, right? The difference between those two voltages. So if I subtract that, I end up with 180 minus J 104. And if we convert that into polar form, that squared plus 180 squared, square root. 208. I'm sorry, it's not 277, it's 208. Okay, it's 208 volts at some angle, which I don't really care about. So if you ever see labels with 208, that is basically the three-phase voltage between two sources. And then it gets different if you're in delta configuration. Yeah, like I said, chapter 24. All right. So just a little fun thing. Next week, final exam. Final exam will cover everything we covered in this course. 50 questions, multiple choice. It'll be available beginning on Tuesday at 12:01 a.m. It'll be available all day Tuesday, all day Wednesday, all day Thursday to about 11:59 p.m. So basically you have 72 hours to get it done. Everybody in here, I think, has taken that before, so you kind of know what to expect, right? Go in and out anytime you want. Our official final exam time is 5 to 7 next Wednesday. I will consider you here if you complete the final exam. So close it up, right? You want to come in here to work, that's fine. If you want to come in here to ask questions, answer questions to make sure you're going in the right direction. Right, obviously not going to give you the answer, just make sure you understand the question. So I will be here until at least 7 o'clock, because that's what we're paying for. If nobody else is here, it's 7:01 or so, I'm out here. But if someone is here and working, wants to continue working, I'll stick around for a while. Till they kick us out. All right, questions? Okay, this time is yours. You work on, get caught up on labs as necessary.